this is NetMaven. Today we're going to make a lab on Cisco SD routing. I'll be able to onboard a Catalyst A1000V to Catalyst SD-WAN Manager when running in SD routing mode. I will push the configuration to the device from the Catalyst SD-WAN Manager and configure embedded security policy and deploy that to the device. Also, I'm monitoring and troubleshooting Cisco IOS XCE routers from Catalyst SD-WAN Manager and the Manager Software Image SWIM of Cisco IOS XCE routers. So let's take a look at today's diagram. I have vManager, vSmart, vBound. The vManager right now is called a manager, and the controller we have is the vSmarter is controller, is vManager, and vBound we call it validator. I have 4 edge routers, WAN routers, Catalyst A1000V, Catalyst A1000V. Here's the site 11, site 12, site 13, site 14. The code I'm running on the router is 17.13.1a, and the version I'm running on the manager, smart and bound, or manager controller validator is 20.13.1. We have onboard the first task onboard A1000V with chassis ID. We need a chassis ID and token ID. From SD-WAN Manager. So we have onboard A1000V at site 12, 13, 14, and already to SD-WAN Manager. The lab, I will to onboard A1000V at site 11 to the SD-WAN Manager. That to onboard device, I will SSH to the device. Now I configure necessary to all site A1000V device. First is to enable NetConfig, enable SD routing, system IP, organize name. This can be any. All the crops are the same, same fabric, and we'll enable vBound. vBound IP is this guy's IP. Our specific a WAN interface is Gigabit Internet 1. And we configured NetConfig starts the confd process on the device. After I configured SD routing block, it starts vDaemon process on the device. The vDaemon process communicates with SD-WAN validator, and SD-WAN manager is the vDaemon process will communicate to vBound and vManager. Next, what I'm doing is to on the SD-WAN manager, we're going to navigate to configuration, certificates. I will filter a list to show SD routing device. Let's pick a chassis number and token ID and activate them on the device. Copy. Go back to the device. Send a command. Request platform software SD routing. Activate chassis. Paste the chassis ID and your token ID. Hit enter. After, I will show SD routing connection summary. Let's show it again. Show around. This way we're going to check anything wrong with the organization name. I will change my organization name. TME routing node. Register again. Site ID 11. I'll show you more about this routing config. We need a bit of waiting. Type in the command again. Now I'm just able to verify the device from a persistent connection to SD-WAN manager using show SD routing connection summary. Go back to SD-WAN manager and monitor device. So I'm able to verify the onboard device and see it is reachable from SD-WAN manager. This is a successful complete onboarding of Site 11 Catalyst A1000V to SD-WAN manager. With this, I have all 4 Catalyst A1000V onboarded to SD-WAN manager. Next thing I will talk about is lifecycle management. The SD routing solution allows network administrator to manage the routing devices from a centralized management plane. Once the devices have been onboarded, they can be monitored from the centralized management plane. We'll monitor or review all devices that have been onboarded to the SD-WAN manager. To do that, we can navigate to the monitor and go to devices. I'll go to overview. In the WAN edge box, we'll click like a full. This also gives navigation to the same place. I see a list of devices or network is showed here. Devices when onboarded in SD-WAN modes have keywords. We say SD routing to next to the device model. The BFD and TLOG columns display as NA since no connection is made to the SD-WAN controller, while previously we called B-Smart. Also, we could do troubleshooting using SSH terminal from the SD-WAN manager. You can troubleshoot the different devices from one GUI using the SSH terminal application on SD-WAN manager GUI. You can go to the CLI to the device and capture the required details. To do that, so I go to Tool and SSH terminal. I could pick the device from here, and a SSH terminal will be loaded up. So this opens the SSH terminal application to the device. Will provide a username and password, and it will log on into the device, from where I will able to capture additional information here. So as a part of troubleshooting and verify reachability to a destination using ping, go back to monitor and devices. From action, or click ping. Pick a source interface. We're using a VPN 0. From the VPN here, we'll pick a VPN 0. That's a transport VPN. There are other VPNs, VPN 5, 10, 11, 12, whatever. And I have management VPN, VPN 5, 12. Click ping to go ahead. See the results at the bottom of the page if it goes through, a test goes through. Now we could do the troubleshoot. Traceroute is a network diagnostic tool to track the path that an IP packet takes from a source to that destination. The tool will show you all the hops from the source to the destination, and the time it takes from hop to hop. So it's the same thing. Go to monitor and devices. Take traceroute. Traceroute Google. Start. And below there is a hop-to-hop detail from source to destination. And we can view the real-time data. We're gonna select the monitor, and I'll go to devices again. For the action, we're gonna pick real time. From the device option here, I can choose many of the features. And we'll go pick the interface statistic. I'm going to use do not filter. And give us the other interface statics. Next, any operational events on an individual device is the overlay network is reported by the device to the SD-WAN manager by sending a notification. Subsequently, the Cisco SD-WAN manager filters the events, notifications, and correlates the related events. So it also consolidates the major and critical events into alarms. So we're also to see this, we'll monitor device ubiquity alarms. For alarms, we're seeing all the alarms, if there's any, for the site. The thing we can see is the events. To the same place, go to events. Here's all the events about site 1 VH Cisco 8000V router on site 11. The next cool things I want to show you is the speed test. We're going to monitor device, find site 11, and when the latency is reported generic, the quickest way is to test it is by doing a speed test from the device to iPerf server on the internet using the WAN circuits as a source. So we're going to navigate to and choose speed test. On the next screen, I will provide a source interface, and I'll provide the iPerf server information, and we're gonna to pick internet iPerf. Click start test. It will initiate a speed test and provide us with the download after speeds. And we see the speed test results here. The other thing is we could do packet capture that will allow me to capture and analyze the traffic on the SD routing device. To do so, I'm going to device, go on to the packet capture. We're going to initiate a packet capture by selecting the target interface and the under a VF. There was a packet capture status. It will show up here. I can choose to stop the packet capture when the packet capture was captured for 5 minutes, or when packet capture file size has reached to 5 megabytes. And I would use just click the menu to stop it. Then the file is ready for download to the local system, or use Wireshark to read the file contents. Okay, when troubleshooting an event, generate admin tag file to capture device state. If the file provides further details of problem and helps in debugging the issue when engaging with Cisco TAC, we'll go to Tool and Operational Commands. Click one of the edge router. I'm going to generate admin tag. Check core and click all. Generate. Also, as part of the life cycle management, SD-WAN controllers and routing devices can be upgraded to the required software version. There are two ways to upgrade SD routing device. we're using SD-WAN manager as a software repository, or use a remote server as a software repository. It's recommended. Advantages of using remote server as a software repository is since the SD-WAN manager resources and cycles are not used to upgrade the device. The cycle is preserved for other important tasks. Also, automatic workflow on a remote server that is used to perform scheduled software upgrades. This functionality is not available when using SD-WAN Manager as a local software repository. I will perform some software upgrades using the remote server. I will do upgrade the Site 14 Catalyst A1000V from version 17.12.1a to 17.13.1a or using a remote server option. So to do that, we'll go to workflow and I'll get software upgrades. Click let's do it. Next. We'll pick site 14. Next. I'm gonna create a remote server. I'm putting the server information. The protocol I'm using is the SCP port 12. VPN using 0. Click add. Well, let's select the remote server. And I will provide an image name for A1000V. I'm going to select the image. And I'll click new. The image name. Click add. The image will show up here and click to select it. I'll choose this, the download and upgrade. Well, make sure it's going to upgrade now. Click next. This time shows me some page and we'll review the detail and click next. Give it check my current task. If process fails, it will show failed and it will take action to see why it failed. Obviously the file name is incorrect and we'll go into workflow. Do it one more time. So wait about 10 minutes. During image this time is copied, installed, and device will be reloaded with the new image. Once done, I will see the device reboots and a newer software version. So I'll pause my video here. Now I'm seeing the software upgrade complete. It completes the software upgrade task. All Catalyst A1000V in the network are now running with 17.13.1a image. I have introduced config push to the device from SD-WAN manager with 17.13.1a and 20.13.1 release. And next, we're going to take a look at this configuration group. A configuration group is a logical grouping of features and configurations that can be applied to one or more devices in the network managed by Cisco Catalyst SD-WAN. I can define and customize this grouping based on my business needs. There are two kinds of a configuration group. One is configuration based on the parcel. Refers to as configuration group, CLI-based configuration group, and the steps involved are creating a configuration group and associated device to configuration group. I will develop a configuration group to the device. Navigate configuration, configuration group. So a configuration group provides a simple, reusable, and structured approach to full configurations in SD-WAN Manager. I can create a configuration group that is a logical grouping of features or configurations that apply to one or more devices in the network managed by Cisco SD-WAN Manager. I also create profiles based on the features that are required, recommended, and uniquely used. And then I'll combine the profiles to complete the device configuration. This lab will create a configuration group for Catalyst A1000V device at site 11 based on parcels. As the first step, I'm going to add a configuration group. I'll create SD routing config. The name I'm gonna give this say AKV CG configuration group. Parcels description is for parcels based configuration group for C8000V. Great. So the next screen, a message is showed up, and to that configuration group was successfully created. First, then I choose to add devices immediately or later. For now, I'll choose to do it later. And I'll go back to the configuration group. I'll click edit. I'll see the ribbon click the ribbon to see all the features associated with the system profiles. Click AAA. Add a feature. We're going to add user. Password. Okay. Any configure that is not part of the system profile needs to be added as part of the CLI profile. Click Save. Scroll down a bit and start configuration. We're going to create a new one. So given name is the Cisco A1000V CLI profile. CLI add on profile. Copy and paste all of these config. Fix it a little bit and click Save. Now I have a configuration book created with system profile and CLI profile. Steps will be create a CLI based configuration group, associated configuration group to a device, and deploy the device. So I'm going to add a CLI based configuration group. So we'll talk about the creating configuration group based on device CLIs and procedures to copy the configuration from the device and pull the device configuration from the SD-WAN manager. So still configuration, go to configuration group, add a CLI based configuration group, gonna provide a name. Choose SD-Routing. Next. On the configuration page, we're going to select your a reachable device and pull the configuration from the device. Now from the configuration pool, and see that the interface gigabit 2 is in admin down state. Okay, it's still up. I will create the variables by highlighting the value from the configuration and click create the variables. To do this, I want to create this. Create a variable. Create it. I'll create a variable for different statics device specific configure, like site ID. Site ID can be a variable. And vbounds will be fine. Host name. Interface IP for the LAN and the WAN. Find the first interface. also the net, quit it. The access list that is used to for the NAT. Once they're done, I'm going to I'm gonna add one more host name. I'm going to save it, the configuration group. Once we have a configuration group created, either parcel based or CLI based, the next step is to associate a device or devices with configuration group. Next, we'll associate the device to the ACI based configuration group. Go ahead, move to the right side a little bit, and we're going to add it. Click associate device. Associate device again. Go through the process overview page, and we'll get an understanding how all line steps, and click and next. Choose side 12, side 13, side 14 to be attached, and the same CLI configuration group. I'll click next. In the sum page, we'll click save. This will save the associated device list. I'll just deploy immediately or to do later. I'll do later. Go back, and I'm going to add it to the parcel configuration group. Associate. Next, associate it to size 11. Next, save. So by the end of the step, I will have site 11 associated with a parcel based configuration group, and site 12, 13, 14 associated to CLI based configuration group. Then I'll come to developer the configuration group to device. So I deploy the configuration group to the device. I push the configuration to the device from SD-WAN manager. So this goes to configuration group. Go ahead to add the parcel based. I would first do the CLI based. Find associate device. Click deploy. Next. So if I wanted to push the configuration to all 3 devices or not, select, and based on the decision, next. Click site 12. There's few parameters that I have to provide. Site ID 12, LAN network. First host name. WAN. WAN mask. The LAN IP. net mask for net. .0. Click to the next. Next, I'll save it. Yeah, we have it. Certain system IP. Then side 14. Go ahead, review everything. Fix that and click next. In the submit page, I'm going to see the list will be pushed, and looks like this side 12 has got a problem back. Okay, give us one more time to see if they're all corrected. We're going to preview the CI. We'll review device configuration page and see the 3 listed devices to which the configuration will be pushed. I'll see the differences to make sure that the configuration is correct. Once verified, I will go ahead, deploy. Successful submission message will show up. That's view deployment status or set in process. Now with this, we have pushed the configuration from SD-WAN manager to the device successfully. Now we're going to push the parcel-based configuration group to the device in a similar fashion. Click deploy. Afterward, the configuration is pushed. In next session, we'll talk about the security policy orchestration, configuring diverse iOS XE security features through the command line CLI or customized ad hoc scripts has historically been a complex, labor-intensive process that is prone to errors. This is especially true for defining granular security policies across zones and containers. Many customers who want DIA, direct internet access at their branch offices, but security concerns hold them back. SD routing can streamline secure DIA deployment on WAN edge routers, offering a simpler approach to securing distributed network. So next sample, I will take you through the SD routing guided security workflow to configure a security policy and push that to the device and devices. There are a few steps we'll do as a part of a workflow. We'll first download UTD image and upload that to SD-WAN manager and create a policy group, create embedded security policy, and associate the device with policy group. Deploy the policy group or change to the configuration group, and so we provide reachability from UTD container to outside traffic. Look at here, we're going to find a 1000V. So what is UTD image? UTD is a container that is required to inspect traffic flow through the device and apply IPS, IDS. IPS stands for Intrusion Prevention System. IDS stands for Intrusion Detection System. And URLF, URL Filter, and AMP, Advanced Malware Protection. As we are running 17.13.1a on our Catalyst 8000V, that's a relevant UTD container can be found from Cisco 8000V Edge software images. We'll navigate to 17.13.1a, and this the image we're gonna download. Once it download, we'll go to maintenance, software repository, and we'll upload to the virtual images. Choose vManager, I pause my video and upload the file. And in the pop-up window, or just drop the image download earlier. Do not refresh the web page or click the web page back button when image is being uploaded. That's fine now. And click upload. I pause my video until image is uploaded. Now image can be seen in the repository. This is the detailed information of the UTP. After UDT is uploaded, I will create a policy group. As the name indicates, policy group is a group of policies tied together. In the SD routing, only embedded security policy is supported in 2013 or 1713 release. SIG, SSIG, SSIE support is available in release 17, 14 or later. So go to configuration, policy groups. I will click add a policy group. The policy group will be is gonna fill in detail for policy group name, solution type, description, and make sure to select the solution type as SD routing. Otherwise, the SD routing devices will not be available when I associate the device with a policy group at later steps. Click create. Then a policy group is created and detail of policy group construct can be seen. It shows embedded security policy that will be created in the next step. There are two ways to create embedded security policy. In SD routing, we support interface-based policies. First, create security policy. I will choose the following options. Here, I will create a security policy and provide a policy name. Device solution here will be SD routing. Here I'll add policies, sub-policies by clicking add sub-policy. I'll create a rule and the subsequent actions for any traffic from a LAN interface, which is the Gigabit Ethernet 2 going to a WAN interface. Gigabit Ethernet 1 should be inspected and applied with IPS IDS, URL filter, AMP. Take a look at the diagram. The traffic flow will be from the LAN to the WAN. In here, we'll be applying IP, IPS, IDS, URL, filter, and AMP. So first, we'll create a source zone. Zone list name will be LAN interface. Pick interface. Gigabit Ethernet 2. Click Add. Let's leave the root name and subscript as is. Next, we'll create a destination zone. Pick WAN interface. Gigabit Ethernet 1. Click Add. Next, I can choose to match certain traffic patterns. I can also match any specific source, destination, or application or protocol. To do that, choose those parameters and provide details. So in case I do not choose any, it corresponds to match all. In action, choose inspect and to configure additional security options by choosing to create a advanced inspect profile AIP. So and associate that to the root. Create AIP will be by providing name and description, and at least create one profile, IPS IDS, or URL filter, AMP, or create all. So here, first give it a profile name, advanced inspection profile. Then let's create a IPS IDS, intrusion prevention profile. Provide the profile name, we'll say IPS profile. Signature, we pick security. Inspection mode, make protection, add. Now we have IPS profile. Also keep going, create a new for URL filter. The word selector is the web category. So first give a name, URL F profile. Make a block. What block is social network, and we're blocking streaming media. Make a moderate risk and click add. Now create a URL filter profile. We'll then create AMP profile. The profile name, AMP profile. We'll pick a none. North America, crowd region, make it critical, and click add. Let's give add. Now we have advanced inspection profile. Let's click save. Rule 1, is created. And I'm seeing matches, all, actions, 3 actions, IPS, action is inspect, UI filter, everything AMP, everything here. We'll go ahead, click next. In the summary page, we'll verify the details. Okay. Click expand it. Submit. Now, security policy has been created. Let's click view all policy security policy to view the list of policies. Embedded policy we have seen is created. Select policy group. Click the ribbon to expand it. Choose embedded security policy. Click save. A policy group with embedded security policy is created. And what's next? We'll associate device to the policy group. Before I begin, I must have created a security policy and secure policy group and associate them to together. So in the section, I will go to configuration. Here, stay in configuration, policy group, and policy group. Here, policy group. Find here, associate to 0 device. Click associate device. Next. Now let's select device, and I wanted to associate with policy group. In this example, I'll pick 12. Next. Continue. Then give it save. Continue by clicking the provision device. Next. So we have associated a device to the policy group. Let's check the step involved in to deploy security policy as configuration to the device. So after provision the device, we're gonna to go for the security policy group, expand it, find one device is associated, click deploy. Still need to go through steps. Now, okay. Let's preview the CLI. This takes a while. These are the pushes policy group configuration to the side 12 device. You will see the policies we're pushing. Click deploy. Let's view the status, task status. Click the icon here to see the audit logs. Cyanide configuration push installs the UTD container on the device. Let's check UTD container reachability. Based on the configuration, once the policy group is deployed, UTD will be installed on the device. Any traffic from source LAN interface will be sent to UTD container for inspection. Next, ensure that traffic from UTD container can reach outside. I will go to configuration groups, edit the CLI configuration group, click edit. Scroll down to find we're gonna add one more interface after the interface 2. IPNT inside. Scroll up, find the net access list, 20 permit IP, the subnet of the virtual interface. It's ending. Let's click save. Is to add IPNT inside on the virtual port group 0 interface that was created, and also will allow network used by the container only access list to be netted. Next time is to deploy. We'll find out the configuration be pushed and click deploy. Configuring security using policy group workflow ensures an easy configuration. Once I configured the policy group, I want to verify the configurations. I will log on to the system LP12 and connect it to the site 12 CAKV, and I'll open a web RDP. What I'm going to do, put a Facebook. CN. It is accessible. Gmail. Yahoo. Oh, notice this accessible. Right, enough testing. I will go to security dashboards and provide the information at a network level. If I have configured security policy on multiple devices, consolidated data from the device that are going to shown here. Here I'm seeing a SecOp dashboard. Security dashboard provides the information at the network level. And now we're gonna see top threads and rule hit. I have rule hit here. View detail. And tells me specifically there's a firewall matching. And top thread. And top thread here, I'm going to make seeing the high risk and malicious files. Go to view details. Well, click the device number in the device impacted to view threat detail at the device level. Click Advanced Malware Protection. And here you see the file. The Cisco Advanced Malware Protection AMP blocks the malware based on the file reputation and uploads unknown file to Cisco AMP/grade for further analysis. This ping shows the number of files, reputation of file and events over a specific time. Choose URL filtering. I'll go back to see the overview. And here, see the details. See the stream media. Social network are blocked. Intrusion prevention. Next, we're going to take a look at the device 360 view. On the page, we're going to monitor and see select device. Or just go to device 360 view. Just click site 12 on the firewall to see how many firewall rules are configured and applied to this device. And click intrusion prevention or select to verify the IPS statistic. URL filtering. I'm gonna see how statics on base of blocked and all allowed rules. AMP. This is showing the statics based on the file reputation. Application performance monitoring and visibility. The application performance monitor feature is a simplified framework that enables you to configure intent-based performance monitors on the device. This will help keep a check on the health of application at a given point in time, and can enable the application performance monitoring globally and reference that on the WAN interface. So this configuration support either on the device CLI-based or device CLI-based configuration group, and or can add it at the port of add-on CLI profile on a parcel-based configuration group. I'll add the configuration CLI to the configuration groups. Find the CLI configuration group, add it. After net config, add explanation mark here. Copy and paste of this configuration after net command line, and go down to the interface 1. After OSPF advertisement, we're going to say performance monitor contact. To monitor context is the FNF monitor and FNF visibility. Okay, here. Next. Visibility. To profile, so we'll apply to the interface. Click Ethernet 1, click Save. Go ahead, add it again. The associate device. Click Deploy. Next, Purview. Some errors, we gotta fix that. Go back. Like that. Find out which part goes wrong. Okay. Okay. Now should be all good. Okay. Save again. We'll try to deploy this again. So we're going to deploy all this CA1000V. Next, let's view the difference again. Now the configure goes through. These are the command lines we wanted to add. Let's just deploy it. Deploy succeed. We'll go to monitor, application. This shows a list of view of different application traffic flowing through different devices or network along with a health of application, good, fair, and poor. I could go to the device. Find application. When time takes, this application will showing up in all the statics. So that's some key takeaways. In this lab, we have covered the different use cases like life cycle management, configuration creation, and push to the device. I create a security policy and push to the device. Next one, application profile monitoring and visibility. So, Cisco SD routing. It provides the convenience of using a unified network management system, the Cisco Catalyst SD-WAN Manager. This allows us to manage all Cisco IOS-XE routers seamlessly, irrespective of their operational mode. Either is the autonomous, non-SD-WAN, or controller SD-WAN. This is the controllers are per set. I configure the 4 routers and users are on the LAN segment. So I can commence with onboarding device in autonomous modes to SD-WAN manager, and then transition into a managing the device. So that includes the monitoring, troubleshooting, configuration, and software upgrades. So I have a capability to configure the security policies and develop them to the device. So that's all about this lab. If you like my video, click the subscribe button below or leave a comment. Thank you for watching.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget